Okay, we are ready to start lecture 21. We're working our way through chapter 3. This is unit 4. Okay, so first of all, let's go back and remember what is a greenhouse gas and what is electromagnetic radiation. Of course, the greenhouse gas is the type of gas that can absorb infrared radiation, and infrared radiation is a type of electromagnetic radiation that falls in a particular region of the electromagnetic spectrum. So we're trying to figure this out, so let's review for a minute what we learned during Unit 3, I guess it was, about ultraviolet radiation. We recognize that there's a continuous spectrum of electromagnetic radiation. This is how energy moves through space. Higher energy moves in the form of gamma rays, lower energy in the form of radio waves. And remember that we can talk about electromagnetic radiation in terms of the particle model, which would be the energy of the photons, little packets of energy that are associated with this moving wave, or we can talk about it in terms of wavelength. And remember, there's a relationship between the energy and the wavelength, and it's an inverse relationship. That is, the longer the wavelength, the lower the energy of that particular radiation. So we took a close look last time at ultraviolet radiation. We all know about visible radiation. Infrared radiation falls to the lower energy end of the spectrum towards compared to visible radiation. And so what we learned last time that was the ultraviolets, especially the higher energy end of the ultraviolet spectrum, some of those photons are capable of breaking chemical bonds. In other words, the energy is high enough to eject electrons from the atomic radius. And remember, a bond, a covalent bond, is a shared pair of electrons between two nuclei, and the ultraviolet light is enough energy to, when absorbed by an electron, to be removed from the bond, therefore breaking the bond. Visible light and ultraviolet light also can, the higher energy UV and visible light can cause electron transitions, electrons to move within an atom from a lower energy place to a higher energy place, but not necessarily break the bond, just cause electron transitions. The electrons then relax back down. That's how we can see color in the first place. So what's the deal with the IR? That's what we want to understand now. What does IR radiation, infrared radiation, do to matter when it comes in contact with matter? It's not high enough energy to break bonds, so it does not break bonds.